Hi, let us continue to the next chapter, yeah? So the next chapter is on linear law. So you will use your MS2, yeah, in this for this chapter. Okay. So let us start. X, okay, and x plus c. That means linear means it is only x. The power of x is only 1, okay, when we say linear. So now what is the law of linear? Okay, the law of linear says that as long as I have the equation, okay, where I can write it in terms of y and then x, okay, the coefficient in front of the x will always be the gradient, and then you will have to plus with some constant at the back, okay, and that constant will be y-intercept. So in this chapter we will use this often, okay, we will use y equals to mx plus c because the linear law says, okay, in every equation or every expression that you have, as long as expression is without the equal sign. So when you have equal sign, it's equation, okay. So every equation, if it's followed y equals to mx plus c, okay, y equals to mx plus c, it will form a linear line, okay, or we can have linear relation, okay. Linear relation means 1 to 1, okay. So if the graph, okay, if we draw the graph of linear, it will be a straight line, okay. Straight line means it's a linear relation. So in this chapter you will see some of the non-linear, okay, equation that we need to change it to linear, okay. So there is another objective in this chapter lah, okay. So one of the objective is to make sure, okay, your equation is always in linear form. Another one is to get linear from non-linear equation, okay. So there's two major objective here in this chapter. So we will see one by one lah, okay. So another thing, so the function or why we have to use this, okay. This linear law is very useful in science, okay, especially physics. So in physics we will use a lot of we will convert a lot of non-linear into linear. I'm not sure whether you have learned, okay, but when you do experiment, okay, sometimes we plot the graph, right? So sometimes we will not plot graph x to y. It's not always responding to manipulated and responding variable, okay. Sometimes we will use other than that. That means we will change the manipulated to in biology, let's say we will change the time for the reaction, okay, to the rate of reaction. So when we change from time to rate, okay, rate is 1 over every second, okay. Time means if we carry out every minute, okay, or every 20 seconds, so we still divide, okay. So that is a little bit on how we use the linear law, okay. Never mind, later on we will see in an example, okay, how the linear law, how we change the non-linear to linear, okay, and how we applied it in our science experiment, okay. Next. Okay, the first question that you will see here, alright, so the first question says, okay, which of the graph is linear relation? So if you see here A and B, of course B is linear equation, okay, linear equation. But do you know that both graph, okay, the equation is y equals to x squared plus 1, okay. So y equals to x squared plus 1. If I use x and y axis as x and y, okay, x and y, you see, this is normally what we do, okay. We plot the graph of y against x, okay, where your axis is x and y, the normal one, okay. And then using this equation you will get a curve, okay, which is non-linear. But for this B, okay, question 1b, okay, you see, I change instead of x, okay, x-axis for x, I change the x-axis into x squared. Okay, so when I make my x-axis into x square, I actually makes the graph from curve to linear, the straight line like this. Okay, so instead of plotting y against x, so now my graph is y against x squared. So when I do that, okay, we actually linearize the non-linear equation. Okay, so y equals to x, if you see the equation, y equals to x squared plus 1, we have make it into y equals to mx plus c, where your y is still y. You see mx, x now is not more x, it's x squared. So your m will be 1. Okay, then your c will be 1. Y-intercept is 1. So you see the graph will cut at y-intercept 1. So this example on self-practice 6.1 is a very good example to show that I can linearize. Okay, I can make a non-linear equation into a straight line by changing the axis. Okay, so that's only purpose here in this chapter. Okay, how to make it linear? You change the axis. So instead of plotting the graph x to y, x and y, you will plot the graph, okay, after you have linearized the non-linear equation. Okay, so this one you just see in your textbook. Okay, which graph show the graph of linear? State your answer. There's a you just read from your textbook lah. What I want you to understand here, the concept of non-linear is the y equals x squared plus 1. So when I say we can change it to linear, means we change it in terms or in a way of changing the axis. Okay, the axis we can change. Later we will see a few examples where we make it into linear. We will only change the axis, the name of the axis, the labeling of the axis. Okay, so the second question you have to do lah. Okay, this is the second question you just do. Okay, which of the graphs show graph linear relation? So state your reason. So you have to plot it out. Okay, you have to plot it out. Okay. Sketching is okay, but it's better for you to plot it out lah. Okay, then you will see which one is linear. Okay, now we will see overall pictures here. So in linear law, in this chapter we will see, as I said just now, and also the non-linear relation. Okay, when the x power or the y is not more power 1, and then the x is no more power 1 also. Okay, so when we have that type of equation, we call it non-linear relation. Now if you have non-linear, you have to change it to linear form. Okay, after you change to linear form, then you will get your linear equation, and then linear equation you will draw the line of best fit. Okay, sometimes you need to do that. It depends on the question, yeah. Sometimes they will just want you to change it to linear equation and that's it. Okay, sometimes they will proceed with drawing the rest line of it. Then sometimes they will ask you for constant, and then sometimes find value. So the last 3 parts here is actually the question. Okay, the question they can just ask any type of question over here. Okay, you will see any of the type. How to draw the line graph and how to draw the best fit line. Okay, when we see the word best fit, it means that it has something that is not fit. Okay, then we have to find the one that is best fit inside. Okay, then you have to learn how to change non-linear equation into linear equation, and then from the graph that you have drawn, you must know how to use your line graph to form the equation if the equation is not given. Okay, or how to use the line graph, okay, to find the values. Okay, so these are the 4 main objectives, okay, that you have to know or have to understand or can be able to do after we have finished the chapter. So what is meant by best fit line? So drawing a the line of best fit, it means that you have to follow certain rules. So sometimes after you make it into linear, okay, since we have all the decimal point, yeah, okay, so you will find that your graph is no more like very straight. Okay, maybe it has some point up, a little bit up, further up, a little bit of down a bit. So how to make a line, how to make a straight line like that? So that means you will have to follow the 2 rules here. Okay, so I get it from your textbook, it's not I create one. Okay, so first thing, you must join most of the point. If you have 5 points, it's the best you can join at least 3. Okay, 3, at least 2 lah, actually, at least 2, and then the better lah, the more the better. Okay, at least 2 of the line, and then if you have 5, if you can join 4, then better you join the 4 lines, 4 dots together. If you cannot, the most you can join is 2, then go ahead. But if you join 2 lines out of the 5 points, okay, 2 points out of the 5 points, make sure the other 3 points is actually evenly distributed at both up and down of the line. Later I will show you what is meant by evenly distributed. Okay, so you must follow these two points or these 2 rules. Okay, when we draw the best line, best fit line. Okay. So linear law says, okay, you must follow the straight line, must follow this one. Okay, so where the M is intersection, M is gradient, C is intersection, X and Y are the variables. So X and Y here I can change. So let us see how to form the line. Okay, graph. Okay, this is my graph. This is my line. Okay, you see I have point A down here, point B and so on. You see all the point is not really on the line. Okay, let's say this example, they have 1, 2, 3, 4, 5, 6, 7, 8 point. There is 8 cross there, so that means 8 point. So out of the 8 point, they cannot touch all the point. Okay, so they can only touch you can only touch 5 points. So you see there is 3 point that is not going to be on the line. Okay, there's not going to be on the line, 3 points. So that means after the point A, you see there's 3 points, but this 3 point, 2 is at the bottom, 1 is on top, so it's evenly distributed. Okay, you cannot have all the 3 points at the bottom, or you cannot have all the 3 points on top of the line. So when we draw the best fit line, so even though the point is like up and down, so you have to try to join all the most number of points. So in this example here, they join 5. Okay, out of 8 they join 5. From the 5, okay, there are 3 here that is not joined, but this 3 is actually evenly distributed, 1 on top of the line, another 2 is below the line. So if this line is 5 and then you have 3 of this point on top, then it's still not the best fit line. Okay, so when we join all the best if you join all the most point, make sure on top and down is evenly distributed, the point that is not joined. Okay, then from the graph here, after we draw your best fit line, okay, we can make an equation for this line. Okay, how to make equation from the line? So you have to see on the line which are the point that is on the line that you can use 2 points to find your gradient. So we have learned how to find gradient before. Okay, so to find gradient, you just use 2 points that is on the line. Okay, if you have 6 points, okay, out of the 6 points, you only touch 2. Okay, 2 points, then you only use that 2 points. You don't use other point that is not touched or is not on the line to find gradient. So from here you can see that the gradient, you just take y1 minus y2, y2 minus y1, sorry, and then divide by x2 minus x1. Okay, and then you get 13 over 18. Okay, then next step 2 you will do for, you will look for y-intercept, which is c. Okay, in our linear equation, y equals to mx plus c. So C, how to get your C? So one of the method is to sub inside. Okay, sub inside y equals to mx plus c by having your y is 1 over y, x is 1 over x. Then you take one of the point here, either you take the point B, here they use point B, or you can also use point A. If you use point A, 1 over y will be 7. Okay, 1 over x will be 1. Okay, so it will get same answer. So your C will be 113 over 18. Another method, if this graph is drawn on the graph paper, okay, you can actually just read it from the paper. Okay, that is also you can get your y-intercept. Okay, now we will see step 3. Yeah, step 3, you just substitute what is your answer. Okay, after that you get your C and the N, you just substitute inside and then you simplify lah. Okay, if you don't simplify, you leave it on as in the first line, also okay. Okay, so this example I got it from your textbook, so it's not new. Just to summarize everything, okay. So when we draw the line of best fit, okay, step 1 you must get the gradient, the M. So when you want to calculate gradient, you must use the point that join the line. Okay, that means if you have 8 point, you only touch 2 points to make your line, so you only use that 2 point. If you cannot use other point that is not on the line. If you have other better point which is on the line where you have nicer points, then you just must make sure that the point that you use is on the line. Okay, that's the only rules. Okay, to find your gradient, make sure the point that you use to find gradient is on the line that you have drawn. Okay, or is driven. Okay, the line that is driven. Okay, step 2, look for y-intercept. So y-intercept, you can either read it or you must extend. Okay, if you draw your graph yourself, you must extend your graph until it touches y-axis. Okay, or it cuts y-axis. So you have to adjust lah. Okay, and step 3, you have to substitute. Okay, the value, you just substitute the M and the C into the equation, but make sure your X and the Y here, yeah, your X and the Y here now is the axis, the label of the axis is not just X and Y. Okay, that's why I use a capital letter here to know that it's not really Y and X, it's just a variable. So when we say variable, it can varies, and it varies according to the X and Y's axis that is given. Okay, now next we will see example 4 that is in the textbook. What I mean by using the point gradient. You see the example 4, they give you the table, but when they plot out, okay, out of the 7 point, okay, 7 point, it only touches 5 point. Okay, so there are 2 points that is not touched. Okay, that is up and down here. Then when they want to draw when they want to find the gradient, okay, they use the last point. Okay, no problem because it touches. Okay, the line touches the last point. And another point they don't use in the middle. You see, they use the furthest one, which is the y-intercept. Can also, no problem. Okay, even though the y-intercept is not in the table, okay, but since it's on the line, okay, I can use it to find my gradient. Understand? Okay, I can still use it to find my gradient as long as on the line. And then for the equation, it's easier. Okay, this one example is easy. Okay, after we find the gradient 1.4, we just substitute the xy. Xy here is just xy, so even easier. Okay, then the intercept is +2. Okay, +2. Okay, so +2 lah. So the equation is this one. Okay, next time we won't leave this answer in 1.4, it's in decimal. Okay, normally we perform equation, we not leave it in 1.4 or something like that. Okay, so maybe we can put into a fraction. Okay, it is okay. If you find 1.4, you substitute with 1.4, is also okay, no wrong. Yeah, okay, can also. But if you want to change to fraction like the previous example, also can. Okay, now so let's see how to change from a linear form to a non-linear to a linear. Okay, so this part is to change from non-linear to linear. So the first step is to get, okay, of course your non-linear equation which is given in your question. Okay, so normally they give question like this. Okay, y equals to ax plus b. So how to change it to non-linear? Okay, you see your x square is power 2. So I just divide by x. Okay, I divide the y with x. I divide here ax square by x. I get ax. Bx divided by b. Divide by x to get b. So you see here, this one will become y equals to mx plus c, where the y, you see y-axis is now this. Okay, instead of having y and x here, okay, like the nonlinear, so I change the y-axis to y over x. Then the x-axis to still remain x lah. Then I will get my linear straight line. If I draw this, I will get a curve. Okay, the nonlinear is a curve, it's a quadratic graph. But after I make it into linear, I will get a straight line. Okay, so that is how. Sometimes we have to re-experience x is power 3 and then x is power 2. So how to make it into linear? Linear means I do not want the x with power 2 or power 3. I just want x power 1. So if I divide with x, I will still have power 1 here, power 2 here. So if I divide by x square, I will get power 1 here, power, no more x square here. So I will choose to divide with x square. Okay, so we divide with x square. Yes, I will get this. Okay, then I compare it with y equals to mx plus c. So my y-axis, instead of y now, it becomes y over x square. The m is the p, the gradient will be the p. And then the x-axis still x, and q will be the y-intercept. So we just put it like this. Okay, one of your practice is to find what is the x, y, and then mc. Okay, y equals to mx plus c. So what are the one y in mx plus c represent? Okay, in the equation. Okay, let us see. So this one, you see the x is with power. So when the x is with power, it's a bit complicated. Okay, we cannot just remove the power or something like just take away. Okay, cannot. So we have to involve the knowledge that you have. Okay, how to bring down the power, how to make the power disappear. So we have to think a bit, and then based on your knowledge, you can actually use log. Okay, so if the first example, y equals to, first the example A, okay, y equals to px plus k. So from here, if I want to bring down the power, or if I want to separate the x and the p, I have to use log. Okay, I put log y equals to log p times x power k. Then when it has multiplied, you can change it to plus. And then the k is power, so I can bring it down. So y axis is now log y. Now x-axis is log x, k is the gradient m, and this one is the constant. Okay, all the alphabet are constant except of x and y are variables. Okay, now second example B. Okay, same thing, I will take log both sides. After that, I bring it down the x. So now my y-axis is log y, my x-axis is still x, the gradient is log b, then the y-intercept is log A. Okay, so this is the example. Okay, next I also get from your textbook some example where you draw the graph and then we find value. So this one I do not want to teach you how to draw the graph. Okay, I believe you know how to draw the graph. So you have graph log y against x. So you see the graph given here. So the value is log y against, and then they give you the scale. So you just draw and then make sure it's line or best fit. So we have said 1, 2, 3, 4, 5, 6. Okay, 6 points. See? There's only 1 point. Of course, there is no evenly distributed. So this point can be down or up. It's okay. Okay, as long as you touch the most point. Okay. So after you have drawn the most line of best fit, then you see there is a dotted line. So this dotted line is not for question A. It's not for this question. Okay? Question A is to plot. But question B, they want you to find the value. So when you find the value, you must use the dotted line. Find a value from the graph. From the graph, find the value. When you find like that, okay, you make sure you do the dotted line. Okay, so you see B1, find the value of log y when x equals to 0.9. So 0.9, where is it? From here. Okay, so 0.9, so your dotted line starts from 0.9. If you can, you put the value. Okay, going up, then your value of log y is 2.0. So So you see the answer log y equals to 0. The second question says from the graph when x equals to 0, what is the value of y? Okay, you see they want the value of y. It's not log y. So you have to find value of y. How to find the value of y? So you see when x equals to 0, log y equals to 0.2. So you have to do anti-log. Remember the previous chapters? Okay, we have learned anti-log. So in order to get value of y, you have to do anti-log, use calculator, you get y equals to 1.85. Remember the graph given, okay, the value that is taken from the graph is follow the axis. Okay, if the axis is x, that means the value here is x. If the value, the axis is log y, means the value here is log y. So to get y, you have to do anti-log. Same goes to the B3 and B4. Okay, you just understand it. It's no nothing new. Just exercise. Okay, then the last question C. Okay, there are 2 points from the graph is selected. This one, the question C is to find the equation. So the equation that we need to find from the line. So again, after we have drawn the line, okay, so you have to find the gradient. So using the point from the graph, please must select from the graph. Don't use from the table. Okay, unless the point on the table is the one on the line. But sometimes on the table the point is 4 decimal place, but when you draw to the graph it's only 2 decimal place. So you use the 2 decimal one to find gradient, not the 4 decimal one in the graph, in the table. Okay, understand? The table is you after you do calculation also you get 4 decimal place. But when you draw graph, normally a graph doesn't give us until 4 decimal. It gives you 2 decimal and at most 3 decimal. Okay, so when your graph is 2 decimal, you use 2 decimal one to find your gradient. Make sure it's from the graph. Okay, this one is very important now. Exam it's really something where we call we will be very headache or heartache, okay, if you lost the point here. Okay, so after you find the gradient, same thing, you find the intersection. That's why we must cut. Okay, must cut the y-axis. After that, after you get your y-intersection, yes, you just put in substitute into y equals to mx plus c. Okay, the next example I want you to I just want you to see the how we make it into linear. Okay, they give you the equation. Just now the example it doesn't give you equation, but this one they give you equation and then they want you to find the value. So you have to be careful. Same concept. After you make it linear, alright, they want you to draw the graph of linear, right? Plot the graph is log y against x. Okay, that means this is the linear one. And then they give you the table is x and y. Okay, but when they want you to plot the graph, it's not more x and y, it's log y against x. So your table, you see here, you have to find the value. So as I said here, okay, sometimes when you find the value x and y, okay, log y, the y means you take from the question, y is 0.3162. So log 0.3162, you get negative 0.50 blah blah blah. Okay, we just take 2 decimal point, and then from this value, the new table that you have come out with, okay, you draw another graph. So this is the line, the first question. Okay, then the question says you have to draw the line of best fit. Okay, so out of 7 points here, so you can see the best fit is you can only touch 4 points. Okay, no, 3 points. Yeah. So this one is not touching, this one not touching. So 1 is on the line, 2, 3. So 3 points is touching. That means you have to evenly distribute 4 points. Okay, the 4 point, 2 is on top, another 2 is at the bottom. Okay, so that is best fit line. So from the best fit line, you have to based on the graph. Okay, now you see based on the graph, you have to find Q and you have to find your P. Okay, so must based on the graph. So log P equals to negative 2.5. So when the value of P and Q, right? So you just choose one of the points Okay, you just choose one of the point. How I know log Q? Log Q is actually y-intercept. Okay, this one is y-intercept, so I just figure out what is my y-intercept and then I get my Q. Then P, log P is actually gradient. Okay, so use the point on the graph. Okay, find the gradient. So after that you can get your P. Okay, and last one is to get value lah. Okay, same thing. So we have finished the chapter, yeah. Okay, so the chapter is quite short actually. The main objective is to change from non-linear to linear. Okay, after that from the non-linear from the linear, then you have to know what is best fit line, and last one you have to just use the graph that you have drawn. Okay, the linear graph that you have drawn, find the equation or find the value. It depends on the question lah. Okay, what they want. So I hope you can finish up the work. Okay, and this homework, okay, I give you a longer duration. Okay, about 2 weeks. Okay, so because it's quite a lot. Okay, the whole chapters. Okay, you can just replay the videos again and again, and then stop at any parts that you need. Okay, explanation, some of the example, or if you cannot, okay, you can ask me. Okay, I can just explain to you any certain small parts. Okay, no worry. Okay, there's small matter. Okay, so I hope you will do your work. Okay, so thank you, and we will meet again very soon. Thank you.